2. And that gives me 18. Then I did 7 times 2. And then I added 1. That gives me 158. Then I added the 79. That gives me 17. And then 7 times 5. Wait. 7 and a 5 is 12. And then 13. And then I did 237.
Thank you. How many of you understand her line of reasoning? You know what I admire about this class? While she was doing that, you were respectfully being quiet and paying attention. I never had to remind you, not one single time. You are truly exhibiting high ability behavior. Did someone do it a different way? Yes. Azariah, is that your name, honey? Or is it Kanaya? I am still learning your names. Come on up here, honey. Show me how you did it.
I multiplied 79 times 3 and was 27. And then I added 21 plus 2 and I had...
How many of you did it that way? Thank you, Kanaya. Is that an efficient way to do it? Yes, it is. How many did it this way over here? Okay, it's a different way, and it works, doesn't it? Mm-hmm. And this one works too. Is there another way that you tried? Deontay, please.
I did 70 times 3, and I got 210. Then I did 9 times 3, and I got 27. Then I added 210 plus 27, and I got 237.
Okay, so we all got the same answer. Thank you. Does that work? Does it make sense? Did anyone do it a different way? Antonio, you might have to work on the upside, the top part of the board. That's where we have more space. You can do that later on, Antonio.
I saw that 79 is 1 less from 80, so I just added 83 times. So then I just subtracted 3 because I added 83 times and minus 1 is 79. And it got me...
Were you able to subtract mentally? Did you have to make those markings, or were you able to subtract mentally?
I could subtract mentally.
Go ahead and show us what you did then. What did you get?
And I got 237.
Does this way make sense? Thank you, Antonio.
Yes.
Does it make sense? Okay. Is there a quicker way of doing that? Kyla, can you explain it to us?
Instead of adding 80 plus, instead of adding 83 times, you could just multiply 80 times 3.
Or, how about 3 times 80? Can we do that? Okay. Then what will we get? 240 minus 3. So we had a similar problem like this yesterday. What I'm trying to find out is, can you transfer what we learned from one problem? Can you transfer it to a different problem? And some of you were able to do that. So I'm going to be looking for that in inquiry math. When you are shown a different strategy, can you use that strategy and transfer it and apply it to a different problem? Okay? All right. Take a look at this. It says, is this a true equation? Support your response. Read the equation for us, please, Ariana.
11 times 2 times 5 equals 11 times 2 times 5.
Now what I want you to do is to not work out anything. I want you to have a discussion with your team, with your group, about what do you think? Is that a true equation or is that not true? Go ahead and begin. We can begin with the question, what do you think? Luis, that's your team over here. Kevin, will you please tell Luis what you think, because I don't think he was listening?
I think the equation is true because it doesn't matter how you group it, it's still going to come out with the same product.
Do you agree with that thinking, Jacqueline? What about you, Luis? Does that make sense to you? Do you think it's true? What conclusions did you come up with? Is this a true equation? Yes. Why? What reasoning did your group use for that? Talk to me about that. Asmati, what did your group say?
My group said that it is a true equation because the second part of the equation is just the same numbers but in a different order.
What do we call this property?
Associative property?
The associative property? And did we group the same way over here?
Yes.
Do you see that we group them the same or differently?
Differently.
Differently. And what do we find out happens when we group them differently? Go on, Kevin.
We found out that if we group them differently, we're still going to have the same product.
I love the way you are using academic language. That was such a concise, clear explanation. Thank you, Kevin. So, here's my next question then. If they truly are equal, and if you had to find the product of this, okay, which would be better for you to do mentally with no pencil at all, no pencil and paper? The first part, where the grouping is 11 times 2, or where the grouping is 2 times 5? Go ahead and talk to your team about that. Do you agree with that, Fantasia? What did he say?
He said that the second problem, 11 times 2 times 5, would be easier.
He said what?
11 times 2 times 5 would be easier.
Well, we're talking about grouping. Why is it easier, the second one?
Because you could easily do 10 times 11.
Because what?
You could easily do 10 times 11.
Is that what you, I see what you're saying, and 2 times 5 is what?
10.
Okay. All right, what did you come up with? Which one is easier? Everyone. Who can explain why the second one, for most people, is going to be easier? Why is this one easier for most of you? Not for all of you, for most of you. Kanai, will you explain for us? The second part is easier. We're talking complete sentences. Excuse me. One person is talking. We track that person and we listen.
The second part is easy because it's only multiplying 5 times 2.
And what is 5 times 2? 10. So why does it make it easier now? Yes. Now it's just 10 times 11, and 10 times 11 is easy because what do you have to do here? What's the answer? What's the product? What did you actually do then?
You just added. You just did.
We added the 0. Okay. These are not 110 ones, it's 11 tens.